So chapter 3, if you haven't reached your limit yet, well, we're going to still use it, but it's going to help us with something known as the derivative. So chapter 3 is on the derivative. So the derivative. In chapter 4, we're going to talk about applications of this guy. And in chapter 5, we're going to basically kind of give us the intro to what many would explore in Calculus 2 if they choose to go further. But it leads us to the fundamental theorem of calculus. So our end goal is chapter 5, which is the fundamental theorem of calculus. Chapter 3 is our big chapter in this course. So it's broken up into 2 parts. So we're basically going to consider the first part is going to be 3.1 through 5. And then the second part is going to be 3.6 through 10. And then 3.11 is going to be later this semester. I think 3.6 through 10 is pretty heavy because it's going to build. This course continues to build every day. So my recommendation is as we finish up a section, always spend some time with the homework in between classes so you can get clarification and understand if there's something that you're missing so that could be cleared up ASAP. But we're going to talk about the derivative, and in section 3.1, we're going to talk about tangents and the derivative at a point. The good news is this lesson is more or less a rehash of things we've already talked about, just using some updated language. So let's go ahead and find the tangent line to the graph of a function, and recall that the average rate of change at a point is defined as follows. By the way, this is a little typo in the note. The average rate of change does not occur at a point, so we should cross that out. The average rate of change occurs at an interval. So the average rate of change is, remember, just the rise over the run. So it's the change in y divided by the change in x. But instead of y, we typically talk about terms of functions. So we have f of x2 minus f of x1 divided by x2 minus x1. So this is the kind of the pre-calculus form of this formula. But remember, what we were using a lot in the last chapter was this f of x1 plus h minus f of x1 divided by h. Of course, we have the restriction that h cannot be equal to 0, but does anyone remember what h represented? It was simply a distance. So if we look at this picture down here below, we have these symbols denoted in a kind of a general example. The average rate of change is the slope of the secant line. And the instantaneous rate of change, remember, is the slope of the tangent line. And the way we found that is basically, which is found by letting h approach 0. So there's the idea of a limit, that we let the distance between x and some other point go to 0. So we can visualize h. You can see h right down here is this distance. And we've seen this idea before, but you can see right here in black is a secant line. And then if you consider like the secant lines drawn by letting the distance between x and x plus h get smaller and smaller, we get this red line right here. And again, that red line is called the tangent line. So we already talked about this a little bit, but remember that the tangent line is the limit of the secant lines as h goes to 0. So the slope of the curve, the slope of the curve is another way of saying the slope of the tangent line at a given point is the number that is defined by the limit as h goes to 0 of f of x 1. Well, I guess they're using x naught or x sub 0. So we'll match the notation they're using above, which is the x sub 0 plus h minus f of x sub 0 divided by h. So we have this phrase, the slope of the curve, which again is just another way of saying the slope of the tangent line. So these are two kind of just phrases that mean the same thing. So if you're asked the slope of the curve, it's the same as finding the slope of the tangent line. And you can see that right here. The tangent line to this curve at point P is the line through P with this slope. So we maybe encountered this exercise, an exercise similar to this back in the first chapter, or not the first chapter, in the last chapter, chapter 2, which is use a grid and a straight edge to make a rough estimate of the slope at the curve point 1 and point 2. This is similar to what we were doing the other day, James, with that homework problem. So you can see point 1 right here, and if you were to go ahead and just draw the tangent line, you're going to probably need to do it with a straight edge, but just estimating it, let's see, it's got to just like brush up against that point right there. So you can see right there, we have the tangent line. So you could imagine the tangent line is just going to be brushing up the curve. And again, we basically got this by letting the points move closer and closer till we got this red line. So how do you go ahead and find the slope of this curve? Well, to do that, what you're going to do is just kind of find two lattice points on it. So it looks like right there and right there. And we can just go ahead and estimate that this goes, let's see, 1, 2, 3, maybe roughly 3 down. So like -3 and then 1 to the right. So again, just this is a simple exercise in saying, okay, what is the tangent line look like? And how do you find its slope? Well, you can always just use a lattice point right there. Overall, when it comes to the examinations, I'm not going to do something that's subjective, whereas like you got to draw it with a straight edge and things like that. We're going to have tools that'll help us find the slope as we go through it. So in this case, m is equal to -3. But the takeaway, if you considered the graph at this point right here, notice it's decreasing. If you looked at this curve, it's decreasing, which indicates that the slope is negative. So that's probably one of the big takeaways. Point 2 right here, if you consider the tangent line of this one, it's just going to be a horizontal line. We talked about this briefly back in chapter 2 as well. A horizontal line has a slope of what? 0. M is equal to 0. And one of the takeaways in this case is notice that this is where a maximum occurs at x equal to 1. So again, just kind of starting to observe the relationships between the graph and the slope of the tangent line, aka the slope of the curve, will be something that we're going to build upon in the coming lessons. So any questions on this first example? Again, nothing as subjective as draw the tangent line and then go ahead and tell its slope on a test, but the main takeaways are, notice the graph is decreasing, the slope is negative. When it's increasing, the slope is positive. When there's a maximum or minimum value, the slope is going to be 0. So again, we've already actually worked with this formula. Let's just do another example and kind of start relating it to the different scenarios we'll run into. So consider the reciprocal function right here, y equal to 1 over x. And we're asked to find the slope of the curve, aka find the slope of the tangent line, for any point x equal to a that is not 0. And again, this not equal to 0 part is just basically saying you don't have to worry about plugging 0 into the denominator. And what is the slope at a specific value of x, namely -1? So before we even get into any of the computation, let's just consider this second question, the slope at the point x equal to -1. If you think it's positive, give me a thumbs up. If you think the slope will be negative there, give me a thumbs down. What do you think? Or if you think it's 0, put your hand in the middle. I see a lot of thumbs down, and that is correct. Because if you look at -1, that's right around here, and notice that the graph is decreasing there. So just the idea that I now have my answer and mine is going to be negative will help me as I go through this computation. So I already have, just from knowledge of the reciprocal function, x equal to negative 1, my answer is going to be negative something. I don't know what yet. I'll have to figure that out. So how do I figure this out? Well, the slope of the curve, the general formula for it is just a matter of taking the limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is a little bit of a heavy computation, but make sure you have the algebra background. If you are struggling with certain algebra, make sure you're putting in some additional practice. The algebra here really picks up compared to what we did in chapter 2. So if you're struggling with some of the algebra, make sure that you're seeking help, asking me, asking Ace, and I'll give more information about Ace on Monday. I've been talking to Kenneth. How many of you know Kenneth? He's one of the ACE tutors, and he's going to come stop by and give us some additional information about ACE and then ask you guys a couple questions on Monday. But that'll be Monday. So let's go ahead and do the actual computation here. F of x plus h means we're going to take our original function, which is 1 over x, and replace the x with x plus h. Then we subtract 1 over x, and then we divide by h. I made one little typo there, so don't write everything yet. I forgot to actually bring the limit along. So we want the limit as h goes to 0 right there. Once we have evaluated the limit, we'll have a formula that we can use to find the slope of the curve, aka the slope of the tangent line. So, of course, try plugging in 0. This won't work well because you're going to end up with 0 over 0. So what you'll need to do is just basically do some algebra to go ahead and work through this. There's a couple approaches that you could take. I'm going to just take the standard approach of getting a common denominator. So in the numerator, so I'm going to multiply top and bottom of that one by h, top and bottom of this one by x plus, hold on, do I want to multiply by h? I don't want to multiply it by h. What do I want to multiply it by to get a common denominator? X. I want to go ahead and subtract it with this, so I need an additional x there. This second fraction I have to multiply by x plus h. Okay, so now we have the limit as h goes to 0 of x minus x plus h over x plus h times x, all of that over h. Say again? It won't just be 0 because, and again, maybe you thought about plugging in 0 initially, because what would happen if you plugged in 0, you would have 1 over x minus 1 over x over 0. You're plugging in for h, careful, you're not plugging in x here. You're plugging in the h as your variable. So we can do some cancellation. The cancellation that will happen is that this x will cancel with this x. So I'm not going to show too much at once. So let's just do the limit as h approaches 0 of, now we have minus h over x plus h. And this h, I'm going to just write like this, divided by h. I'm going to switch this horizontally because sometimes it's a little easier to see. When you divide by h, notice that this h is going to cancel out with this one because you're multiplying by the reciprocal. So you can think about this as multiplied by 1 over h. So that h cancels with that h. So we ultimately have, let's see, the limit as h approaches 0 of minus h, minus 1 over x plus h. Now plugging in 0 for h, we get, oh, I forgot something. Okay, I forgot my x here. So I forgot that. Sorry about that. So that x should be there. And we still have an x here. Plugging in 0, we get 1 over x plus 0 times x, which is 1 over x squared with a negative in front. So what is this right here? This right here is a formula we can use to find the slope of the curve, aka the slope of the tangent line, at any point in the domain. So the answer to the first part, find the slope of the curve at 1x at any point x equal to a. Well, this right here is the answer to part A. And then the answer to part B is literally just taking 1 over, just let x equal to -1. You get 1 over -1 squared, which is 1 over -1, which is, 1 over +1, which is -1. Everyone okay with that? Where I got everything so far? Anyone need clarification? What is that -1 now? It is the slope of this line right there. Because this right here is x equal to -1. So what you're going to want to start paying attention to is what are you given and what are you asked? I'm given an x value. I'm asked for the slope of the curve. Now let's look at B. Where does the slope equal -1/4? Here, are we given a slope or are we given an x? We're given a slope equal to -1/4. So here, m is equal to -1/4. Where is the x value? So how do I do that? Remember, this thing right here is what m is equal to. So this is to figure this one out. You have -1 over x squared equal to -1/4. When you solve this, again, you could cross multiply, reciprocate. This ends up with x squared equal to 4. And then when you take the square root, you get x is equal to plus or minus 2. This plus or minus 2 is right there. And, well, let me wrap it around right here. So there's -2, there's +2. And if you look at those 2 points associated on the curve, these m's right here have a slope of -1/4. Everyone okay with what that x equal to plus or minus 2 is now graphically? So how do I find -1/2 or +1/2? If I have the x value, how do I find an associated y value? Plug it into the original. So again, if we need y, plug into the original, which in this case is y equal to 1 over x. So you can see right there, that is where you would get, that's where you get the plus and minus 1/2. So start making those distinctions. When I'm given m, I'm probably looking for x, and when I'm given x, I'm looking for y, or excuse me, for m. And if I need a y, then I'll plug back into the original. Part C is a simple question that says, what happens to the tangent to the curve at the point A, 1 over A, where as A changes? So basically, we're just saying, what is happening to the tangent as we consider different values of x on this function? In other words, it's asking, is the function increasing, decreasing, or constant? If you think about this part right here, is it increasing, decreasing, or constant? Decreasing. And what about this part right here? It is also decreasing. So what we have right here, so what happens to the tangent of the curve? Well, the tangent, it is always has a negative slope, because 1 over x is always decreasing. We won't use this word too much in Calculus 1, but for those of you taking Calculus 2, this is the idea of a monotonicity or monotonic function. So mono meaning one, and then tonic is going to give us the direction. So one direction or always decreasing in this case. So the slope of the curve is the same as the slope of the tangent line. And on the next page, we talk about the derivative at a point. The expression right here, which we've already talked about several times this semester, where h is not equal to 0, is called the difference quotient. Again, it's the difference quotient, just the terminology. When we apply the limit as h approaches 0 to the difference quotient, this limit is also called the derivative at x equal to some x naught. So where x naught is some x value that you can plug in. So the derivative of a function at a point x naught is denoted with this notation. This right here is read as f of, well here, let me just read the point specifically to this little dash. That dash is read as prime. So this is f prime of x naught is equal to the limit as h approaches 0 of x naught plus h minus f of x naught divided by h. So we have a bunch of phrases. What do these phrases have in common? The slope of the graph at a point, the slope of the tangent line to the curve at a point, the rate of change at a point, the derivative of a function at a point. What do those all have in common? Literally, the phrase at a point, but maybe we can also say, what do they have in common? Everything. They're different ways of saying the exact same thing. So whether we're talking about the slope of the graph, the slope of the tangent line, the rate of change at a point, or the derivative of a function at a point, they are all the same thing. So usually just different contexts, like this one is talking about just looking at the curve. This is when we're talking about tangent lines. Derivative is when we're talking about functions, and rate of change is when we're talking about physics. So they all just have slightly different contexts, but they're all the same thing. So for in number 3, we're asked to find the equation for a tangent line to the curve. So again, in other words, we're also asked to find the slope of the curve. We're also asked to find the derivative of the function. And then we're asked to sketch the curve and the tangent line together. So notice here, we're given, here's some x that we're given. So we're here to ask to find f prime of x equal to negative 2. So we're asked to find f prime of negative 2, which is equal to the limit as h goes to 0 of f of minus 2 plus h minus f of minus 2 divided by h. And hopefully you're thinking this looks very familiar, because it is. It's something we did back in chapter 2. So to do this, we would just have to do some substitution. We would just consider the limit as h goes to 0. And our function here is the one, this quadratic one. So it's going to be minus 2 plus h squared plus 2 times minus 2 plus h. So that is the first part. Then we have minus f of minus 2. So this is going to just be, you can plug it in if you want, or just realize that that is just going to be 0. And then it's going to be divided by h. Is everyone okay with what we got to so far? So of course, this is really an algebraic exercise at this point. Remember, to square means to multiply by itself. Go ahead and see if you could finish this process before before me while I take attendance. So let me go ahead and give you the opportunity to finish up that limit while I take it. Feeling better? I'm going to go ahead and start putting up the work silently so you could check your work and finish up if you're not done. So the computation for this limit is you end up with -2. So what we're saying right here is the slope of the tangent line at x equal to -2 is -2. We're also saying that the slope of the curve is -2. We're also saying the derivative at -2 is -2. Does this answer make sense? It should, computationally, but also if you look at the graph at x equal to -2, you're right there. At that point in the graph, is the function decreasing? It is. So this answer makes sense. Now, what is this right here? Realize that this is also the m of the tangent line. So if you were asked to go ahead and find the tangent line, which we are, we would find that we would get y minus 0 equal to -2 times x minus a -2. So we find y is equal to -2x. And then, let's see, this would be -4. That, if you look at that, we would have the tangent line right there at the y-intercept of -4. Then let's see, go 2 down and then 1 to the right, or you can go the other direction. I'm just getting us enough points there. But you can see right here, we do have this tangent line through said points. Oh, hold on, did I missed that a little bit. So -4, right, let's see, 2 up, 1 to the left, there we go. All right. Any questions on that one? So the main new thing here, I'll go highlight it, is this prime notation. F prime of -2 is -2, which is the slope of the tangent line. Let's go ahead and look at the next page. So on number 4, we're asked to find an equation of a straight line having the slope of 1/4 that is tangent to the curve y equal to the square root of x. So let's go ahead and just have in our mind the square root of x. So let me go ahead and put this right here. So square root of x looks, so let's see, 1, 1. Then we have 4, 2, 0, 0. So just getting kind of the shape of the graph in my mind, it looks something like this. And we're asked to find the equation of a straight line having slope of 1/4 that is tangent to the curve. So, what are we given here? Are we given an x value, or are we given the slope of the tangent line? We're given the slope of the tangent line, which again is just, in this case, is going to be f prime. We can say just f prime of x is another way of notation, another notation that we use. The derivative of the function is equal to 1/4. So let me go ahead and kind of cut out the middle work a little bit. Let's just say I did this as the derivative is equal to 1 over the square root of, well, it'll be 1 over 2 square root of x. So that is the derivative. I just did it quickly in my head because I know the shortcut that we're going to learn in the next lesson. You're like, can I have it today? Maybe. So, if this is the derivative, what am I going to do with this 1/4? Am I going to set it equal to 1 over the square root, or 1 over 2 square root of x, or am I going to plug it in? If you say plug it in, give me a thumbs up. If you say set it equal, give me a thumbs down. And the thumbs down is correct. The reason is, what is this 1/4? It is the slope. The derivative, f prime of x, is another way of saying the slope. So what we're going to base, what we're given, we're given that f prime of x is equal to 1/4. This right here is the general formula that we can use for the slope of the tangent line. So what we'll do to go ahead and find out where it is at, let's go ahead and find an equation. Let's go ahead and set it equal to. So this is going to be 1 over 2 square root of x. Set this equal to 1/4. Let's solve this for x. So we reciprocate. So this is 2 square root of x equal to 4. Divide, and we end up with x equal, or square root of x equal to 2. And then lastly, we square, and we get x equal to 4. So what this is saying is right here, at x equal to 4, if we draw this tangent line right here, it's not drawn perfectly to scale. It's a little hard because I don't have, looks something like this, is going to have a slope of 1/4. But let's go ahead and actually get that equation now. So if I want the equation, let me change to green here. So I want the equation for the tangent line. If I have x, how do I find the associated y? I use the original function, which is this one right here. So y is equal to the square root of 4, which is 2. So now what I need to do is to get the equation is just going to be y minus 2 is equal to 1/4 the slope, which is then times x minus 4, which I found, right? Well, let me go around this way. Everyone see where that all came together? Great. Of course, when we're asked for an equation, we typically want it just y equal to slope-intercept form. So we get y minus 2 is equal to 1/4 x minus 1. And then lastly, add 2. So we get y is equal to 1/4 x plus 1. So if you were to do that, so then we rise 1, run 4, you can see right here in green is the tangent line. Again, I didn't draw my curve perfectly, so it was a little bit off, but you can see that is how you find the equation for a tangent. Anyone have any questions on that? All right. Let's go ahead and look at number 5. 5, on a scale of 0 to 1, the effectiveness E of pain-killing drug T hours after entering the bloodstream is displayed in this accompanying figure. And we're asked a series of 5 questions. Let me go ahead and give you about a minute to read through those questions, and then I'm going to have you go ahead and pair up with 1 or 2 neighbors around you and just discuss it, and then we'll come back together and make sure that the ideas are all solidified. So go on and take a minute, read through those, kind of get some general ideas in your mind, and then I'm going to have you pair up with 1 or 2 around you just to discuss it, and I'm going to kind of walk around and just kind of see kind of what the general feel of the class is. But a lot of ideas right here. All right, let's go ahead and come back together, fill out the final few answers. I will say that calculus is one of those subjects that is very computation heavy, but it's also very conceptual. So sometimes that makes it very difficult just as you put the ideas together. Don't procrastinate in the homework or in asking questions. I'm always ready to help. So let's go ahead, and I was listening, and many of you made some very good observations, which are correct. So A, at what time does it appear to be increasing? Can I get a volunteer for this answer? Let's go here, Grace.
Hours 0 through 3.
So hours 0 through 3. So it's going to be, notice that our x-axis is kind of our t-axis. You'll find that our horizontal axis is always going to be where time is represented. So this is going to be 0 is less than or equal to t is less than or equal to 3, or you could have used interval notation if you wanted. I should make one little adjustment though here, because if you're looking at 3, it's not really increasing anymore, so I should go ahead and drop the equal to sign right there, because at 3 it is changing. And we'll talk a little bit about one-sided derivatives here as we go. But you can see right here at 0, what was actually happening is it's starting. So I'm going to go ahead and drop the equal to sign there as well. So again, it's going to be in terms of interval notation, 0 to 3 with parentheses, or inequality notation. You can use this. Honestly, at this point, if I don't really care which one we use, we'll kind of use them interchangeably. So any other questions or comments or follow-ups you have about A? All right. B, what is true about the derivative at these points? So let me get another volunteer. What does your group say is the true about the derivative at those points? Let's go to Emma. So the function is increasing, or you can think about the graph is increasing. So typically when we're talking about the derivative, we're talking about the slope of the tangent line. So you could also say that the derivative is positive. And again, just starting to see the connection between these. So notice here that the derivative is positive on the interval 0 to 3. Because you can see up here, down here, the derivative is negative. Up here, the derivative is equal to 0. Okay, at what time would you estimate the drug to reach its maximum effectiveness? Let's have another volunteer here. Let's go over to James, sorry. What did you say? 3, that is correct. So you can see right here, this is the maximum, so it's at time equal to 3. Very good. What is true about the derivative at this time? Let's go, Destiny.
It's at a constant, so it's equal to 0.
Yeah, so the derivative, so what we can say is that f prime of 3 is equal to 0, or you can say the slope of the tangent line is 0. All right. Any questions or other comments on C or D? Yeah, say.
This might be like a weird question.
Ask away.
It's a different question, but I thought that C was 1.0 because I thought the definition was P, so that would be down.
So the question is, at what time would you estimate it? So here's something to also start paying attention to, is we're talking about time. So time is going to come from our horizontal axis right here. If it asks about what was the effectiveness of the drug, that's when you would look at the vertical axis. So that's another thing to start paying attention to, that the unit that you're working in is actually going to give you a lot of information about what you're looking at for your answer. Is that what you were asking?
Yeah.
So the 1.0 is the effectiveness. Here was asked about the time. It said, what is the effectiveness? And then it would be 1. And lastly, what is true about the derivative as in time, or let me read this correctly. What is true about the derivative as time increases the 1 hour before your estimated time? So it's this part of the graph right here. How would someone describe that part of the graph? Raul?
It's still increasing, it's just like increasing less.
Great. So if we think about this part is still increasing, but is increasing less. So you can imagine that there's this idea of it's slowing down. So in other words, we're starting to think about the rate of change of the rate of change. So this is starting to think about I'll just say f, we'll just call this our function f, is still increasing, but it is slowing down. Because if you look at the steepness of the line here, if you think about this also makes sense if you think about a drug in the bloodstream. It goes in, it has a lot of surface area, it's being absorbed very quickly, but as it reaches its peak efficacy, it's not going to have as much surface area to dissolve and be absorbed in the bloodstream, and the bodies are also starting to kind of utilize it. So one thing before you pack up, before I say that, if you look at the next page, this idea as f is still increasing but is slowing down. So guess what? We can also think about the derivative as a function. Is the derivative increasing or decreasing, and not just the original function? So we're going to talk more about that tomorrow. If you have any questions, feel free to stick around. Otherwise, have a great day, and I'll talk to you later.